Alright, Logic fans, welcome back to our second video on section 5.4. So this is video 5.4b, and we're sort of discussing this new issue of failed correspondence that arises when you're interpreting using the Tableaux technique a quantificational sentence involving the identity symbol, right? And so we notice that when you have A is identical with B, you have to make sure that the property that A has, B has to have, and vice versa. So they either both have to be positive or they both have to be negative, right? Because if they're the same thing, it couldn't be the case that A has a property that B lacks, right? Now, let's continue this discussion because a similar thing can occur with a sentence involving relations and identity. So let's take this step by step. First, pause now and provide me with an interpretation that makes sentence 2 here true. Okay, so hopefully you came up with something like this, right, where these are both positive, and that's fine. This is indeed an interpretation that makes this sentence true, and that's all you would actually need to present, and that's totally fine, okay? But where can issues of failed correspondence possibly come in? Well, let me give you a little bit of a hint here. So notice we've got A is identical with B being true, and we've got RAB here being true. What values must occur here and here and here to avoid failed correspondence, do you think? We'll talk about it together in a second, but pause now and see if you can figure out what must go in here given this sort of setup, okay? Pause now. All right, hopefully you've had a chance, okay? But this is interesting, so let's take this one at a time, okay? If A is identical with B, all right, and RAB is true, then what has to happen to RAA? Well, it's got to be true too, right? Because this B is really just an A, according to this. Okay, so this one's going to have to be true as well, and similarly for the others. The exact same logic applies to all of them. So, you couldn't have a situation where this was true and then this one was true, as we have here, and then one of these is false. That would exhibit failed correspondence, okay? That would violate the laws of identity, and it's exactly analogous to the case that we did here in 1, okay? If they're identical, they have to bear the same properties and the same relations, okay? So I just wanted to point that out to you. You have to be a little bit careful about that. Now, again, for 2, you can just present this one, but if you have on a test these ones presented, you better not leave them blank. Okay, or if the professor asks you to list all of the relevant ones, so in this case, with the 2 objects A and B, there would be 4. With the 2 individual constants A and B, there would be 4, right? 2 squared total relation sentences that you can form from that, and you would have to fill them all in this way, and that would be the only way of making this sentence true. Okay, now if you want to make it false, of course you just need to make one of these false, and that's totally fine. Okay. All right, let's keep looking at examples and talking about failed correspondence a little bit. And this may be a really good time to note something here. So while we're talking about failed correspondence, typically when we present identity tableau, we do not present sentences like this. And the reason we don't present sentences like these two, even though we may present this one and we may present this one, okay, we typically don't present these for the reason that they're trivial. So we will get these as more or less as an axiom in chapter 6, but if you had to guess what the truth value of a statement like this is, and you had to guess what the truth value of a statement like this is, what would you guess, right? Well, of course, these statements are always true, right? So you can never have a false case for a sentence like something is identical with itself. Okay, they always have to be true, and so we typically don't present them because we regard them as trivial, right? They're sort of assumed as a feature of identity, and any identity tableau that did this would automatically exhibit failed correspondence because it would not be following the proper laws of identity, which is that, one of them is that everything is identical with itself. Okay, and again, we will discuss that in chapter 6. So we typically won't be presenting these because they're trivial and they're always true. in addition to that, another way that failed correspondence can be exhibited is this way. So let me point this out to you. We can, suppose I had this true. Okay, what needs be must this be? Well, of course, this has to be true too. Okay, so typically we won't present both of these. We'll just present one of them, and it's understood that the other one thereby has to take the same value, right? So if this one were false, right, what value would this one have to be? Well, it would have to be false also. Okay, it would absolutely have to be false. And so we typically just present one of these as opposed to both of them, just to simplify things a little bit. But if you had a situation like this, that would count as exhibiting failed correspondence, and therefore we would disregard it as a proper interpretation of a sentence. It doesn't make the sentence true or false. It's just sort of like a nonsensical interpretation. Okay, so any interpretation that exhibits failed correspondence, that sort of violates the laws of identity, we're going to automatically disregard those. They don't count as interpretations that make the sentence true, nor as interpretations that make the sentence false. They have to follow the laws of identity. Let me point out another one for you, which is kind of interesting. So these can get to be a little bit sophisticated, but let's try this one. Sorry. So what would it be? It would be like this. So, you know, if these are both true, what must this one be? Right, this one's got to be true too, right? Because otherwise you're going to exhibit failed correspondence. Because, and again, this is something we had some occasion to discuss in Chapter 4 when we were talking about sort of the formal relations or the formal properties of identity. But identity is a transitive relation, and again, we will be proving that in Chapter 6. But if these first two are both true, then this one has to be true as well. Now, if one of these is true and one of these is false, for example, like this, then you could have a plus or a minus here, and that wouldn't exhibit failed correspondence. That doesn't violate any law of identity, which is kind of interesting. Okay, so those kinds of things can be totally fine. All right, one last trick question here about these kinds of things that we're noting. So let's suppose, for example, this was false and this was false. Right? Now, from a purely logical point of view, can I draw a conclusion about what has to happen here? And the answer is no, you cannot. This can go either way. This can go this way or it can go that way, and those are both perfectly fine. From a purely logical point of view, this does not exhibit failed correspondence, nor does this exhibit failed correspondence. Okay, so that's some nice technical notes for us, and they are noted in the text as well. So let's do some examples that involve the quantifiers. Okay, so for these examples, we're going to be doing our interpretations in three objects, A, B, and C. So please provide me with an interpretation in three objects that makes sentence 1 true, and also an interpretation in three objects that makes sentence 1 false, and we'll come back and do it together and give you plenty of practice with the identity statements and quantifiers. Pause now. Okay, hopefully you've had a chance, but okay, the best way to start this, okay, we're just going to go through this together. You have to start with understanding the sentence, okay? So what does this sentence say? It says, everything in my domain. Pick anything you want out of Santa's bag that's got A, B, and C in it, okay? So three objects or three individual constants. You pick A out, it's guaranteed to satisfy the following description. It's identical with A, and it has the property F. You pick B out, it satisfies this description. It's identical with A, and it has the property F. You pick C out, so everything, it's identical with A, and it has the property F. C has the property F. Okay, so I've got my domain with A, B, and C, and then I've got my F of X, right? And then for the identity statements that I present, I did not present A as identical with A. I could have, right? But we regard that as kind of trivial. Right, so for the object A is identical with A, we kind of regard that as trivial. You can present it and it wouldn't do any harm, but I'm just sort of showing you this. But we definitely have to write down that A has the property F because A is this way. It's identical with itself, and it's got the property F, okay? The object B has to be identical with A. So this one, B is identical with A. That's going to have to be positive, right? That's going to have to be a true statement, and B has to have the property F, okay? And we're going to have C having the property F and also being identical with A, so that's going to have to be true. So this is the only interpretation, right? So imagine these gone, okay? This isn't corresponding to this anymore. This is the separate identity table, okay? And it's saying that B is identical with A is true, and C is identical with A is true, okay? And yeah, so what it's just doing here is effectively making this sentence true. Everything satisfies this description on my three objects. They all do. Therefore, it's true, right? Now, I've got to do an interpretation according to which this is false. So for at least one thing in my domain, A, B, or C, it's got to be the case that it doesn't satisfy this description. So one thing's lacking, F, would automatically do it, okay? But, you know, you can have things like, you know, you could have everything being F and then have C not being identical with A, and that would make sentence 1 false as well, okay? And notice the potential for failed correspondence issues. So since you have up here in the true interpretation, you have B is identical with A and C is identical with A. It's like everything is identical with A. So you couldn't have this. Not only would that fail to provide an interpretation that made this sentence true, it would exhibit failed correspondence, okay? And so it wouldn't even be like a legit interpretation, okay? Our interpretations have to respect the laws of identity. So, yeah, and that's the basic idea for how you do problems like this, okay? Let's squeeze in, actually, let's move on to a separate video and we'll finish these two. So look for 5.4C where we will complete these examples. We'll see you there.